Okay, good evening. Welcome to
MathyMath number
36.
36?
Or 37. Sorry, I'm trying to get the color. Oh, hopefully it'll show up in the video. This is problem 25 from the 1999 AMC8. This is the one you looked at this morning, right? Mm-hmm. But you ran out of time. So just very quickly, I want to talk about this problem because it's actually a pretty neat problem, and it's very similar to the Michael Persian stuff we did yesterday. Do you remember that?
The Pick's theorem stuff?
Yeah, we're just looking at triangles and talking through what the area is.
Mm-hmm.
So it says points B, D, and J are the midpoints of the sides of triangle ACG. See that? B, D, and J. Points K, E, and I are midpoints of the sides of the triangle JDG. JDG, see that? See the midpoints? Etc. If the dividing and shading process is done 100 times, and the first three are shown, and if AC equals CG equals 6, then the total area of the shaded triangles is nearest to what? Okay. Do you understand the problem? Mm-hmm. Okay. How do you want to approach this problem?
Well, you can look at where it divides off into smaller triangles. So if you see, you have three triangles that have the same area.
Okay.
So this makes me think that it would converge to a third. The area would converge to a third because you have a bunch of thirds of triangles.
Interesting.
And a third of our triangle is 6. So the area should be 6. I mean the area is 12. No, the area is 18, so a third of it should be 6.
Okay. Is it going to be exactly 6?
Well, no, because you're going to have a little bit at the top.
Why?
That's unshaded, because you're only doing it 100 times. You're not doing it forever.
But it's going to be awful darn close to 6.
Mm-hmm.
That's pretty cool. I mean, this is problem 25, right? So this is supposed to be a pretty difficult problem. But if you think about it in some of the ways that we were talking about with those Michael Persian problems yesterday, it's not too bad. What else could you say about this problem?
Well, you could look at the squares and notice that you have half the area of the squares.
Okay.
And then you have the triangle with this congruent triangle tacked on.
Interesting. What do you think would be a little bit more difficult way to approach this problem?
If you tried finding the area of this, finding the area of this, finding the area of this, all the way up.
Yeah, and you're going to have to sum essentially an infinite series.
Oh, pretty infinite series.
Well, nearly.
Yeah.
All right. Hey, cool. Good job.